Hi, my name is Chen Wang, and I am from National Taiwan University. I will present FlickBoard, enabling trackpad interaction with automatic mode switching on a capacitive-sensing keyboard. Okay, this is a modern-day laptop. This is what it looks like. In order to enter text, we push the buttons here in this part. This is the keyboard, and in order to move the cursor, we touch and move our fingers on this area. This is the touchpad. This is what it looks like to operate on a laptop by moving the hand back and forth from the keyboard home position to the center of the trackpad. Fitts' law tells us the greater the distance to travel, the greater the time costs. Several works proposed methods to reduce that distance d. For instance, thumb sense allows users to move the thumb only to make contact with the touchpad, and then press any keycap by another finger to perform a mouse click. Another approach to reduce travel distance is to merge the components into one. For example, touch and type combined a keyboard with a touchpad. However, it requires explicit manual mode switching by pushing a switch button on the side. Digits is also a related work. A touch sensing surface controls mouse cursor. Users push harder to enter text and slides across the surface to control mouse cursor. Some user behavior could be changed to adapt to such system design. So, from the related works, users need to switch modes by themselves. We are not aware of a dual functional keyboard that automatically switches between keyboard mode and cursor mode. And is it even possible to accomplish auto switch between these two modes? The answer is no. So, I would like to thank you all for coming, and there is no contribution for this paper. Okay, I'm just kidding. The answer, of course, is yes, or else I wouldn't be here today. So why yes? Okay, that's what we want to focus. Why yes? The answer is a user puts both hands on the keyboard while typing and puts one finger on the trackpad while cursor control. It is an obvious difference between typing and cursor control. Therefore, we believe it is possible to do an automatic mode switch using such features. Therefore, our goal is to create an automatic mode switching keyboard. So let's officially introduce FlickBoard. In order to accurately and fluently control the cursor in this large red area, the 2D sensors must be packed densely and should not be intrusive for user experience. That is, the 2D sensors should be made small in size. We chose capacitive-sensing technique to meet our hardware requirements. FlickBoard is a silicon keyboard film with a 58 by 20 sensor grid. This is the entire hardware system. It includes the keyboard sensor grid, wave signal generator, receivers, and so forth. Each receiver consists of an amplifier, a switch, and a low-pass filter used to handle small signals and reduce noise. So we have chosen capacitive sensing technique, and the stage of hardware signal processing is complete. This is the raw image directly from the hardware. We barely have a clue where the fingers are located. So, but the touch point positions should be shown as this expected image. So how do we get from the raw image to the expected image? The raw image is upscaled and blurred. We get this. It is thresholded, binarized, and undergoes Kelman filter. And finally, we get this clear image. And it is shown as this video. So, we now have a clear image. Next stage is to collect user behavior. We recruited 30 participants for training data collection, average age of 21, all right-handed. The tasks must be common for most PC users. Task 1 includes typing a specific sentence, changing the font size, inserting, and resizing a photo. Task 2 includes browsing the social network site, commenting a post, and uploading a photo. Participants are not allowed to use hotkeys or shortcuts. So, it took an average of 6 minutes to complete both tasks for a single user. 150,000 frames were captured from all participants. 42% are blank frames with no contact with the keyboard. The blank frames are discarded. So, what do we do with the frames that we just collected? Type hover swipe is a related work which proposed a method called motion signature that accumulated weighted finite previous frames into a single frame. The frames are downscaled and being trained using randomized decision forest. We have tried numerous numbers of frames in a 5-fold cross-validation. The more frames referenced, the greater the accuracy. By adopting 30 reference frames, the FlickBoard system has high accuracy rate, low false detection rate, and an overall accuracy rate of approximately 98%. For leave one user out cross-validation, the overall accuracy is 84%. However, the accuracy ranges from 49% to 95%. The results show that user behavior varies quite much from person to person. So all the stages are complete. Let's take a look at user behavior. During the task, we observed several user behaviors. 19 out of 30 of the participants raised their left hand while using trackpad mode unconsciously. All of the participants used only one finger while performing trackpad mode interaction. So these observations show a significant difference between typing and cursor control that can clearly be classified by our system. 20 users operated on the center of the keyboard for trackpad mode, and 9 on the right of the center, 1 on the bottom right. Such user behavior assists us to design a better hardware. For instance, the sensors can be more dense on the center and less dense on the rest of the keyboard to improve user experience. There are limitations such as sampling rate. Our sampling rate is 14 Hertz that causes cursor to move choppy. The system requires calibration on startup. However, the sensor value may drift in time. We still have noise in our system, and these will all become part of future work. In conclusion, we built a device that combines traditional keyboard and trackpad, require no manual mode switching, resulting in greater performance on a PC and laptop. Our system has an overall 98% in a 5-fold cross-validation that requires only 6 minutes for a user to train. Thanks for listening.
Actually, the validation, you did a validation on the data on the tasks that you, from the task that you collect the data, right?
Yes.
So can be the case for probably that the accuracy is a bit overestimated. So for example, if you tried on the different tasks, have you thought about that?
Actually, for the tasks we just did, that involves pretty much a lot of mode switching. Well, yeah, of course we will try more tasks on a GUI system. So yeah, so it will, maybe we'll have different results. Yeah, we haven't tried that yet. Okay.
Hi, I'm Sean from Raleigh. So if I understood this correctly, your detection between modes was if one hand disappeared or if a finger changed position?
Actually, that's being sorry. Okay. That is actually kind of different. Well, we are not using threshold mode. We are using machine learning. It really depends on how users kind of use the device. So not really just by detecting if the right hand is off. So yeah.
So you train for each user individually?
Yeah, we're training for each user.
I was just wondering if you thought about using specific gestures to change between mode, so you could do a circle.
That will be manual mode switching, and
Yeah.
I don't want that for
Yeah,
this for this paper. So yeah, well, good idea. Yeah, still a great idea. Thank you.
It's a very fast question.
Okay, very quick question. Keystroke often includes one finger landing during the keystroke. However, the time is very short. Then the cursor isn't moved during the keystroke.
Can you repeat that question again?
Yeah.
Sorry.
So one finger landing is often happen in keystroke when user are typing. When typing, only one key are pressed, and thus only one finger is contact with the keyboard. Then that condition is very similar to the pointing condition. So isn't that cursor moving slightly during the typing?
You mean if it's kind of like if a person is only using one finger to type? Is that
even if human use 10-finger typing, during the typing only one finger is contact with the keyboard surface?
Yes.
Yeah, then
you can discuss.
Oh,
Yeah, can we discuss? Sorry about that.
Okay,
Thank you.